So hello class, welcome to our new topic which we'll be working on calculus differentiation really. Now, um, I'm not going to talk more about there are basically two principles in differentiation. There is the first principle and then there's the second principle of differentiation. The first principle is actually the longer process, but it explains a lot of what is really going on when you say something is being differentiated. Now, differentiation is actually it's actually something that works with change. You hear the word change. Differentiation is all about change. It's all about calculating what is the minutest sort of change that can ever happen. Now, that's why when if you are going to if you become try for engineers and the rest, you work with differentiation and integration a lot. So I was trying to skip the major intro on how the differentiation come about, but I'll just enter into applying the first principle of differentiation. Maybe later on I will drop a YouTube video that talks about how the first principle of different or how differentiation came about, like what's calculus really, what's this change, this rate of change about looking for. But okay, while I'm teaching, maybe you might even get the gist of what's really going on in differentiation. So therefore, let me wipe this off and then start off my class. Okay. Now, where's my marker? Let's start. So first principle of differentiation. Um, Now we work with what they call functions. In differentiation, this what we work with what we call functions. A function is just um, a particular input that gives out a desired output. For instance, if I say let's say 2x and I say 2x, I'm looking at, okay, let's say 2x is equal to, let's call it a y. If your x is 1, your y will become a what? A 2. If your x, I'm just giving for value of x, if your x was to be 2, your y will become a what? A 4, right? It means that for every input you put in here, you get a desired output, right? Now that's what we call a function, really, just the very simple way of putting what they call a function. Okay, now if that's what we call a function, okay, let me not use that, let me use my cleaner. If that was called a function, then in differentiation we'll be working with functions, and in functions you present functions mainly with what? This value f of x, or you call it a y. So either I write f of x means the function of x, where your x is actually the value you are imputing and your y is a new value that is coming out, or your f of x is a new value that is coming out. They are the same thing. This one means the function of your x. So if your x is the value you are putting in, the function of your x will be the new value you are getting, or you can call it a y. Therefore, if I have a particular question like this, let's say my y, which is equal to my function of my x, so we want to differentiate according to first principle of differentiation. Let me show what happens here. I hope you've heard of what they call limits, because I'll be working with what they call limits here, but don't worry, I will explain it while I'm teaching, while I'm using it. So if you want to work with this, now first of all we'll first, let's call this our equation 1. Then for our equation 2, let's say that this particular y, let's add it with a very minute change. Remember, in differential we're working with what? Minute changes, small changes. The most how much of a change can something get to? So let's add a minute change. That minute change is called a delta y. You call it a canonical delta y. So this particular stuff, or I think it's also something like this, they mean the same thing. They mean the same thing in mass, and it's all about, this thing talks about what? Change. It's all about a very small infinitesimal change. So let's say y plus a minute change will give us a what? Remember, whatever I do in this side, you also have to do it in the other side. So it will be what? This will give us an f of, let's say that particular input. Now your input also had a little change as well. Now let's call this, before I call that, let me wipe here off. Let's call this your equation 2. Now solving these particular two equations together, I can just say let me subtract the two. Then I can say let me subtract 2 minus 1. That's equation 2 from equation 1. That will be what? Y plus change in y minus y, that's if I bring in so on, is equal to what? F of bracket x plus change in x minus what? F of x, right? Yeah. So solving this, y minus y is out, so we only have a change in y is equal to what? This particular one still stays, f of x plus this minus f of x. Okay, now the next thing is that we now divide through. We divide through by a change in x. So this is the sequence for first principle I'm just going to show you. Therefore, to be what? A change in y divided by a change in x will be equal to what? Your f of x plus change in x minus f of x all over what? Your change in x. Remember, whatever you do in this side, you have to also do the same side. Now, are we done? We are not done yet. The last thing we need to do is to now find the limit as this change in x tends to 0, because in differentiation we are trying to find the least changed as it is going down to 0. So we take the limits as this change in x tends to 0. So that will be what? Change in y, change in x is equal to what? F. Now what it means that wherever you see this change in x, put it to be 0, right? Let this change in x be equal to 0 for this change in x. So f of x plus this x minus f of x, I've not solved it yet, over the change in x. Now before I do that, this particular stuff called limit as x tends to 0 for your change in y over your change in x is actually called your what? Your dy dx. Now that's how this particular dy dx came about. It's just a short way of writing limit as your change in x tends to 0, as your delta x tends to 0. So therefore you write as what? Your dy dx is equal to, now it's not dy over dx, it's dy dx, dy dx. Okay, so I can wipe that off. So your dy dx will be equal to what? Now this limit as this tends to 0 will make every x, this change in x, to tend to 0. Therefore this particular one here will tend to 0, everything will tend to 0. But for now I want to leave this like this because this is just the formula for the principle of that, for your first principle in what do you call it, in differentiation. So I will leave this. Actually there's nothing that can happen here again, so I will leave this in this particular case so that when we begin to solve, we will now see how to apply this. Now let's take a particular question in solving. So let me take my screen down to this other side. Okay, so I don't know why my screen is not moving too fast. Okay, so let's take this particular question. Oh, that's bad. Okay, so let's take this particular question. Let's say differentiate using first principle, and let's solve for, let me see what we want to have in my book here. Okay, so find the derivative find the derivative of, let's do for the first part a x, and then we'll do for b also, let b be x squared. Now let's find the derivative of x for the first one. Solution for this particular x, we know that it will be what? Our f of x, remember, our y, which is equal to our f of x, right? But in this, for this particular one, we are seeing that our x is equal to what? Our x, we don't know what it is, just f of x still. So it's still like saying y is equal to what? F of x, right? Okay, so it's like saying our y is equal to our x, and our f of x is just x. So our y, then as f of x is equal to x. Now let's now solve this particular question. Now the next thing to do, what? Let's call equation 1. Our equation 2 will be what? Y plus what? Plus your change in what? Y will be equal to what? Your x plus your change in what? X. Remember what we did here? Then what's the next thing we do here now? This is your equation 2. So we now let's subtract equation 2 from 1, and that'll be what? Y plus change in y minus y is equal to what? X plus change in x minus x, right? So what happens here? Y minus y is out, so we have change in y is equal to what? X minus x is out, so we only have change in x straight away here. So what's the next thing we do? We now divide through by what? So we divide through by a change in x, and that will be change in y over change in x is equal to change in x over change in x, and that will change in x will give us what? 1, right? Yeah, since they're dividing each other. So we have a change in y over change in x is equal to 1, right? The next thing we have to do is to do what? Take limit, right? So take the limit. Take the limit as change in x tends to 0 for change in y, change in x, and that will be equal to what? 1. And remember I told you that this limit is actually called what? Your dy dx. And so if you want to take the change in as change in x tends to 0, we see that there's no value change in x here, so we cannot put it as 0 at all here. So therefore our dy dx is equal to just 1. Remember your dy dx is the same thing as this. So since we know that this particular one is just equal to 1, there's no dx to turn it to 0, you just value 1, so dy dx is equal to what? 1. That is why we know that when you differentiate any algebra number that doesn't have a power, it will give us what? 1. So if I say dy dx of let's say y is equal to 1, dy dx of z is equal to 1, dy dx of 4x is equal to what? Just 4, because it's like saying x will only become 1 and then 4 times 1 is still 4. So that's how dy dx happens. So but this part, sorry, I made a very very big mistake. This particular one I called y is meant to be still with x. So because since I'm working with dy dx, not dy dx, so this is dy dx. So here also will also be, I can here also be x. So since we're working with x as the dy dx. Okay, now let's take another question. Let's take this big question, which is our x square. Now let's move our screen down and see what we have. So for this x square, let's take the screen over to this way. And then, so for our b part, we have differentiating x square, right? So here we know that what? Our y is equal to what? X square. Then therefore, let's cross equation 1. Equation 2 will be what? Y plus change in y is equal to what? X. Now this particular x, remember this is what you are changing, not the x squared, so it will become what? X plus change in x squared. So look at this, look what I did here. Some people might just write x squared plus change in x. No, this is wrong. You are changing the how I don't know what to call it, but you're changing this particular input. So it's not just only affecting this square, it's not just affecting the x, it's affecting everything inside this x. So this x plus change in x will now become the new input. So to be carrying what? Raised to the power 2. Now continuing, we can now subtract. So we can subtract 2 from what? 1. And that will be what? Y plus change in y minus y is equal to what? Let's open this one. It will be what? X squared plus what? I think it will be 2 change in x, right? And then plus what? Change in x squared. That's delta x squared. Okay, then minus x squared. This my minus x squared came about because I'm subtracting equation 2 from equation 1. So I've expanded this one to be what? This. Then minus x from this x squared coming in. Now solving, we know that y cancel out y, and then we have that change in y is equal to what? X squared plus what? Plus 2 grad x. So in fact you can see that x squared can also cancel out x squared here. So definitely I can just continue writing what? Let me put this one very well. That'll be what? 2 change in x plus what? This squared. Oh, sorry, I made a mistake. Here is actually meant to be what? 2x change in x. If you open these brackets, please, you can do it and see what I mean. If you open the bracket here, will be 2x delta x. That's, let's put this delta x in brackets, that will not solve what in 2x delta x. So therefore here will be 2x delta x. Okay, now the next part is to do what? Divide through by what? And that's divide through by changing what? X. That's delta x. So that will be delta y. Let's put an equal sign. Delta y delta x is equal to what? This delta x plus this raised power 2 over what? Delta x. Now what's the next thing? We now bring in our limits, or our dy dx. So our dy dx is equal to the limits as delta x tends to 0 of delta y delta x, which is equal to what? 2x delta x plus delta x raised to power 2 over what? Delta x. Now remember I told you this is now turning to 0, and we can see a delta x here and a delta x here and a delta x here. So what do? First of all, I can use delta x to divide through. Is that not so? If this one cancels out, this is 1, and so we must also cancel out this because we must cancel out each of them. Therefore we have that what? Limit as delta x tends to 0 of delta y delta x is equal to 2x plus delta x, and then we have this is dy dx. What's wrong with me? So this is dy dx. Therefore our dy dx, now let's now take the limits. If this is turning to 0, it means that anywhere I see delta x, I should put it as what? 0. So this delta x becomes what? It becomes 0. So there's no delta x here, right? Because they say delta x is tending to 0. So this delta x becomes 0, and then my final answer is what? Just what? 2x. So therefore, know that dy dx of x squared is what? 2x. Is that okay?